Hello, geometry students. This is Mr. Allen here, and today we are going to look at section 6.6, and that's going to finish up chapter 6, and it is on trapezoids and kites. Our objective today is to verify and use properties of trapezoids and kites. So here on the left, we've got ourselves a kite. So here's a kite, and then here on the right, this is a trapezoid. So let's make sure we understand what these things are. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So this is important. So the parallel sides are what we call the bases. And then the non-parallel sides, we call those legs.
Mr. Ramirez, please call 4461.
Sorry about that interruption.
Mr. Ramirez, please call 4461. Thank you.
And then we have some things called base angles. So angle A and angle B are what we call a pair of base angles. A pair of base angles are two angles that have a common base. So A and B are a pair of base angles, and C and D are a different pair of base angles. I should note that A and D are not base angles. So let's look at our first theorem here, theorem 619. And this theorem says if a quadrilateral is an isosceles trapezoid. So an isosceles trapezoid means that the legs are congruent. If we have an isosceles trapezoid, it turns out that the base angles are congruent. So if this trapezoid TRAP, is a isosceles trapezoid with legs TR and AP being congruent, then the corresponding base angles will be congruent. In other words, angle R will be congruent to angle A, and angle T will be congruent to angle P. So let's look at an example of that. So here we have a trapezoid. This is trapezoid CDEF. We know that it is an isosceles trapezoid because we can see that these two sides are congruent. Those are the legs. We know that the measure of angle C is 65, so they ask us to find the measure of angle D, E, and F. Well, first of all, we know that angle F is a base angle, and since this is an isosceles trapezoid, we know that angle C has to be congruent to angle F. Therefore, the measure of angle F also has to be 65 degrees. So there's our first answer, and it basically requires no work. To find the angle, let's say D, we're going to use the fact that since these two sides are parallel, since DE, and I'll call that a segment, is parallel to CF, which is also a segment, we know that the measure of angle C plus the measure of angle D has to be 180. In other words, 65 plus, I'll just call the measure of angle D X. You know what, maybe I'll just leave that as the measure of angle D. That way I don't have to go back and do that again. The measure of angle D has to equal 180. So we just need to subtract. So if I were you, I would grab my calculator, turn it on, and I would do 180 minus 65. So that tells us that the measure, make sure I got my ink on, the measure of angle D is going to be 115 degrees. And by the way, since the measure of angle D is 115 degrees, guess what the measure of angle F also has to be, since this is an isosceles trapezoid. Okay, our next theorem, theorem 620. If a quadrilateral is an isosceles trapezoid, so again, we're dealing with an isosceles trapezoid, then its diagonals are congruent. So if we have an isosceles trapezoid again, then it turns out that the length of segment BD has to be the same length as segment AC. So those two segments, those diagonals, have to be the same length. All right, so let's talk about one more thing involving a trapezoid, and that's something called a mid-segment. We've already looked at mid-segments for triangles, so this is really probably no surprise to you. The mid-segment of a trapezoid is simply a segment that joins the midpoints, that's what this point is over here and this point over here is, the midpoints of the two legs. Now it's important that you know that the mid-segment has to do with the midpoints of the legs and not the bases. So our final theorem involving trapezoids today is the trapezoid mid-segment theorem, and it basically says this. If you have the mid-segment of a theorem, like in this case segment MN, then it turns out that all three of these segments are parallel. So that's what this says. Now here's the next thing. It turns out that the length of the mid-segment, that's MN, is the average of the other two guys. It's the average. In other words, you add them together and divide by 2. So that's what that equation is saying. So let's see that in an example. So here I have a trapezoid, and I guess I probably should have said that this is a trapezoid. So this is a trapezoid. We are told that F and G are midpoints. Therefore, we know that FG is a mid-segment of this trapezoid because these are the parallel sides. We also happen to know that AB's length is 12 and DC's length is 24, and they're asking us to find the length of FG. So we will use the formula from the previous page to realize that the length of FG will be equal to 1/2 the length of AB, which is 12, plus 24. And so we can add those two together, and we're going to get 36. And then 1/2 of 36 is 18. So the length of FG is 18. So this length right here is 18. And that was using theorem 621. I guess I have two examples here. I apologize. This one's involving algebra. I did want to do an algebra one, so let's go ahead and look at that. So we're going to use the same formula again, and the best way I think to start this out is just to write the formula. And the formula is the mid-segment here, which by the way, the mid-segment here is QR, that's given, is equal to 1/2 the length of the bases. So that's going to be LM plus PN. I'm going to go ahead and write the formula out explicitly. So x plus 2, now I'm substituting what QR is equal to 1/2 times LM. Well, what's LM? Well, it's 4x minus 10. Oops, I put one additional set of parentheses there I did not need. Let's get rid of that. And then plus 8. And that's the PN. All right, so now we're just going to work this out. So we're going to get x plus 2 equals 1/2, and then that's going to be 4x minus 2. Now I'm going to go ahead and multiply. Let's just go ahead and multiply both sides by 2. So when I multiply this side, the left side by 2, I get 2x plus 4 using the distributive property. When I multiply the right side by 2, the 1/2 becomes 1. And so we're getting closer here. I'm running out of room. I'm going to move this up here. So now I'm going to subtract 2x to this side, so that gives me 2x here. And I'm going to add 2 to this side, so that's going to give me 6. And it looks like x here is going to be 3. And this question doesn't ask us to find these lengths, but we could verify then these other two side lengths. This just asked us for x. Okay, so now we're done with the trapezoids. Let's look at a kite real quick. A kite is simply a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. So these two sides are congruent, and these two sides are congruent, but for example, these two sides here are not congruent. And furthermore, these two sides are not congruent. So we're only going to deal with one theorem involving a kite, and here's what it says. If a quadrilateral is a kite, then the diagonals are perpendicular. So if we have a kite, ABCD, then I'm telling you the diagonals are congruent. In other words, they form a 90-degree angle, a right angle. So let's go ahead and look at an example involving a kite here. So we have a kite. The kite is DEFG. And we want to find the measures of angle 1, 2, and 3. Well, first of all, the measure of angle 1, that's easy. I'm just going to go back and look. That's what this theorem's telling us. So angle 1 has to be 90 degrees because it has to make perpendicular lines there, right? And if it's perpendicular, then it's a right angle, and if it's a right angle, then it measures 90 degrees. So there's the measure of angle 1. So that was pretty easy. Now let's look specifically at this triangle here. This triangle here, we can see that this angle is 52. We know that angle 1 is 90. So we know that 52 plus 90 plus the measure of angle G. Actually, let's not call it G. Let's call it angle 2. That might be a better way of saying that. The measure of angle 2, because it says 2 right there, is equal to 180, because that's what all triangles are. And then I'm going to figure out what the measure of angle 2 is. That's a 2, sorry. I'm going to use my calculator here just to make sure I don't make any careless mistakes. So I'm going to do 180 minus 90 minus 52, and I get an answer here of 38. So the measure of angle 2 is 38 degrees. All right. The only thing left is to figure out what the measure of angle 3 is. I think I'm going to leave that one to you to figure out. I'm going to erase this stuff up here, and I'll let you try to figure out what do you think the measure of angle 3 is right there. You maybe already know. I'll put a little question mark there. All right, so that was example 4. I've got one more example and then one little slide after that. So this problem, we've got a kite again. And this time it says find the side lengths of the kite. So first of all, since this is a kite, we know that this has to be perpendicular. And it tells us this in the picture too. But that has to be true if this is a kite. Look at this triangle right here. Look at triangle WXU. That is a right triangle. That's what we call it. It's a right triangle. That means the Pythagorean theorem applies. I'm going to call this side here, I'm just going to call it side C. So we know that 16 squared plus 12 squared has to equal C squared. You probably remember a very important theorem from Algebra 1. You maybe even knew it before that, called the Pythagorean theorem. That's what I'm using here. I'm using the Pythagorean theorem to find this side length. And so let's go ahead and do that. I'm going to erase my little C right there. And again, I'm going to use my calculator just to be careful here. So we're going to do 16 squared, which is 256. Then we're going to do 12 squared, which is 144. And then that is equal to C squared. So C squared is equal to, well, I got to add those two together, which is 400. Now, how do I get rid of that squared? Oh, I got to do the square root. So you just got to do the square root of 400, and C turns out to be 20. In other words, this length right here is 20. And by the way, if that length is 20, can you guess what WZ is? Well, it's a kite, so they have to be the same by definition. So I'm going to write that WX equals WZ, and remember that means the length of those sides is 20. So I've answered half of the questions. This question says find the side lengths. I found 2 of the 4. So now I'm going to leave the last 2 to you. How would you find the length of XY? This side right here. And I'll give you a hint. You're going to have to use the Pythagorean theorem. And the other hint I want to give you is this. It doesn't come out to be a whole number like this came out to be 20. It's going to be a decimal. Okay, so that I'm going to leave that one to you. So here's a real quick concept summary of this section, actually this kind of whole chapter, but particularly this section. So this section we kind of focused on kites and trapezoids. So if we have a quadrilateral, if there are no pairs of parallel sides, it could just be a quadrilateral. But it could be what we call a kite. None of the sides of a kite are parallel. If only one pair of sides are parallel, it's either a trapezoid or an isosceles trapezoid. And of course, if it has 2 pairs of parallel sides, we call that a parallelogram. And of course, if it's a parallelogram with 4 right angles, it's a rectangle. Or if it's a parallelogram with 4 right or 4 congruent sides, it's a rhombus. And if it's 4 right angles and 4 equal sides, then it's called a square. So this is kind of a nice little way to encapsulate the big ideas of this chapter, chapter number 6. We are going to stop it there, guys. So thank you so much for your time.